Hey, this is Brock Lemire's, and in this video we're going to talk about making a DC measurement using the digital multimeter or DMM. Okay, so I have my DMM right here, and the measurement we're going to take is on a 9-volt battery. Okay, so when you look at a 9-volt battery, voltage always has two terminals. Okay, so it's 9 volts across two terminals or between two terminals. And on a 9-volt battery, it says right here that it's 9 volts. But then it also tells you what the plus and the minus is in terms of which one of these connections are positive and negative. So the little guy is positive because you can see the little plus sign, and then the kind of the fat dude is the negative, and you can see that right here. So these two terminals right here, where we're going to measure voltage across. On DMMs, the way that it works is you'd use the selection dial and you turn it to DC voltage, and remember that DC voltage measurements are where you're over here with the V in the line, so that means constant or DC, direct current. And what you have to do on most DMMs is you have to know the range of the voltage that you're approximately going to measure. So that's why you see things like you have 200 M, 2000 M, 20, 200, and 500. So what this does is it basically adjusts the display to produce the number of digits that reflect your measurement. So for example, if you were going to measure 2000 volts, it might not fit on this display. So you have to kind of put it into a mode, well, not 2000, let's say, let's say 500. It might not fit on here, and so it moves the decimal place over so that you can actually see what's happening here. And yeah, and so, okay, so for this measurement, we're gonna go to 9 volt. And what these numbers mean is this is like the maximum up to that maximum. So if you're in between 2000 M, which is 2 volts, and 9 volts, you want to be in this measurement right here. So you want to put this dial on the 20, and that means we can go up to 20 volts. And we'll look at what if we change those. Okay, so I'm going to come over here, and what I'm going to do is I am going to put the black on negative and the red on positive. Now remember, you got to plug the leads into the right connection. So I always have one into common, the black into common, and then I use the red, and I have a choice between either this one or this one. I see over here that it says volts, ohms, milliamps, and sine wave or function generator. So I'm going to plug it into this one because it has the V. Okay, this would be used for high current measurements. Okay, so here I go. I'm going to put this right on here, and let's see what happens. Holy moly, we got a voltage, 8.98. So first of all, you notice it's like, well, it's working. The second thing you notice is that it's not exactly 9 volts, and that's totally true. Okay, when you get new batteries, they tend to be over 9 volts, and as they get older and older and you use them, they tend to slowly go down until they're dead. Okay, so all right, that's cool. One of the interesting things about voltage and DMMs is that if we did that measurement backwards, we would actually see a negative voltage because it's with respect to the common. So when I put common on negative, that means it's the lowest voltage, and then I say the red is above it, so it's 8.98 volts above common. If I switch that around, then it is like saying, okay, my common now is at the highest point of the voltage, and I actually get negative 8.98. Okay, so that's one of the things to watch for when you make voltage measurements. If you're like, what in the world, I got a negative voltage? Well, it's just because you probably have the voltage leads backwards. Let's take a look at what would happen if you had this in a different location. So put it on 2000 M, and let's take our measurement again. And notice that it just doesn't quite fit on the screen. So it's like you get this, it's like, what in the world is going on here? And that's just because it's expecting only up to 2 volts. If you put it up to 200, it will be able to handle this, but it might display it a little bit weird. Notice that it's 0.8 or 8.9. So I'm like, oh, I'm off by a little bit. Well, no, I'm not off by a little bit, but notice that I lost one of my significant figures. So I lost one of the digits of my measurement because it is getting ready to display something up to 200 volts. Okay, so that's just kind of the difference between that. Okay, so that's as simple as it is for measuring a DC voltage. So let's look at one last thing when we're talking about DC voltage and batteries and breadboards. Let's look at how we can distribute this 9 volts across our breadboard. So here is our breadboard again, and you'll notice that, let me turn that off, see if it's a little easier to see. You'll notice that I have these power rails, okay, that we talked about, and I want to connect the red across to everything, and I've done that by using these jumper wires right here. And I've also connected the blue all together, so every blue on here is connected together. But I have this battery that I would like to get into this thing. I'd like to have plus 9 volts between red and blue everywhere on here. Okay, so one of the ways to do it is you could just hold a wire on here, but that's kind of tough to do. And so one of the things they do is they make these little 9-volt battery clips, and these are really cool because you can clip these on here and then it brings it out to a barrel jack. Okay, and so a barrel jack basically has the outside is one part of the connection and the inside is one part of the connection. So this one, the outside is the negative part of the voltage, and the inside is the positive. So then to interface that with your breadboard, they have this little barrel jack connector that you can purchase, and what this does is it takes that connection, so you can plug it in, and then these pins right here are actually the plus and minus of the 9 volts. This one on the side is just a mechanical connection. It doesn't connect anything, but the way that this works is the one down here, the furthest away from the jack, is the positive of the 9, and then this one that's in the middle is the negative of the 9. Okay, so I'm going to plug this in, and what I do, I've already done this. I already put the wires in here, so it'll just pop right in. I'm going to put that right in there, and what I did then is I added a jumper wire from this negative part, from the positive part of the 9 volts over to the red, and then I have one from the negative over to the blue. And so then now what I can do is I can come in here and I'll just plug in this battery and see what happens. Okay, so I plug that thing in, and now I'm ready to start taking a look around and see if my voltage actually came in. So now the big thing I got to do is make sure that I'm in the right holes here, and it looks like it appears that I am. Okay, so I've got that in there. Now I'm like sitting here going, well, how do I know it's distributed everywhere on my board? Well, what I can do is I can come over to the DMM and let me put it back in this mode, and then what I can do is I'm just going to measure a couple of points on the breadboard to see if I have 9 volts. So I'm going to go ahead and take some jumper wires and got this and this, and I'm going to plug these buddies in, and let's look at this strip right here. So I'm going to make sure I have a strip here and a strip there. So I plug it in the red and the blue, and there, lo and behold, I got my voltage. So I've got my 8.98, and then let's check over here. I plug it in here, and I plug it in there, and voila, 8.9. And I come over here, let's go all the way over to the very end, and I can go boom. So I'm going to pop that little buddy in there, red and blue, and the wire's a little bent. So I just pop that buddy, just kind of wiggle, find a different hole, it's better. There we go. Okay, so I got it there, and lo and behold, 8.9. Now, why did I do that? This is jumping ahead a little bit, but you can actually now access the ground, the blue, and the plus 9 with circuitry. So let me show you what might come in your future. Let's turn on an LED by driving through some component that's called a resistor. We don't know how that works yet, but I'm going to plug that in where I grab plus 9, comes across the resistor to this terminal strip, and then I can take an LED and I can go from that terminal strip to ground, and boom, I've got an LED that is lit up, and I know that it's on, so I know that I've got power everywhere, and there you go. And so that's kind of the reason that you want to distribute your 9 volts across your breadboard, because you can build little circuits over here and get access to the voltage, over here and get access to the voltage, and so on and so forth. Okay, so that is it for this video. Hopefully you now can make a simple DC voltage measurement and also have a strategy to distribute the DC voltage across your breadboard. All right, see ya.